The profound silence of deep space is so profound that even the concept of sound seems lost within it. Yet, what would happen if this silence were broken, even for an instant? Global leaders would panic, communication systems would fail, and despair would spread across the world. On the screen, chaos erupts. And at the center of it all, a countdown proceeds relentlessly. Viewed from space, a colossal object hurtles toward Earth. No screams, no despair, only a blinding flash. Then, a massive dust cloud rises from the oceans, swiftly engulfing entire continents. The blue planet gradually turns grey, the world extinguishing like a candle suffocated by air. This is the apocalyptic vision humanity often imagines, an object from the dark void roaring toward us with the dread of inevitable doom. Yet this time such an apocalypse did not come to pass. The interstellar visitor, 3I Atlas, did not collide with Earth. It had already flown past the Sunday and was gradually receding from our solar system, returning to the boundless darkness of interstellar space. Yet what it left behind truly perplexed and unsettled scientists. For 3I Atlas behaved unusually, unlike a typical comet. It did not display the characteristic tail when approaching the Sunday's heat. Its light reflection patterns also deviated significantly from expectations, appearing instead as if propelled by some force accelerating its forward motion. This object from beyond our solar system, after its close encounter with the Sunday, seemed to be challenging the physical laws governing all other celestial bodies in the universe. 3I Atlas is humanity's third recorded interstellar visitor, but unlike its predecessors, it has sparked not only scientific curiosity, but also a series of anomalous phenomena, leaving the scientific community divided. Some believe it is merely an unusual comet from a distant galaxy, while others speculate it might carry something beyond our current understanding. For months, telescopes worldwide have strained to track its path, yet 3I Atlas seemed to fade into the cosmic shadows. That is, until weeks ago, when a faint radio signal was detected, pointing directly toward its location. This was a nearly imperceptible sound, merely a minute absorption at a specific frequency. Yet it was enough to reignite all the questions lingering in scientists' minds. If 3I Atlas lacks a comet's tail, what is emitting this signal? If it's moving away from the Sunday, why does it still react to solar heat like a living entity? More importantly, what other unknown secrets does it conceal? The story of 3I Atlas is not one of destruction, but of mystery, of a visitor emerging from the depths of darkness, leaving behind layers of enigma as it departed. In our ongoing exploration, we will trace every clue from the initial captured signal to the latest observational images. For sometimes, the seemingly innocuous things are the most unsettling. Though 3I Atlas did not destroy Earth, it upended our established understanding of the cosmos. Before delving deeper into this unknown realm, if this topic sparks your interest and you harbor curiosity about the universe's mysteries, please support our exploration by liking and sharing this video. Join us alongside those who believe countless secrets worth listening to still lurk in the depths of space. The first sound from 3I Atlas was neither a piercing scream nor a thunderous explosion, but an almost imperceptible echo, a tiny ripple in the silent backdrop of radio waves. The Meerkat radio telescope, standing on the arid plains of South Africa, precisely aimed its massive antenna at the predicted location where 3I Atlas was streaking across the sky. Yet what it captured was not an active signal, but an absorption signal. Specifically, an extremely faint disturbance at 1.6 billion hertz. Amidst the cosmic background noise, something was blocking a portion of the signal from distant space. It was this subtle obstruction that revealed the presence of a simple yet profoundly significant molecule, the hydroxyl radical. These fragments typically form when cometary ices decompose under solar radiation. This marked the first time 3I Atlas left an audible trace, clearly indicating it had indeed responded to our star's heat. Yet this radio echo was not what all scientists anticipated. It wasn't the first detectable trace left by 3I Atlas, but it unequivocally proved this interstellar visitor responded to the Sunday's heat. Yet this echo differed significantly from expectations. No bright comet tail, no visible gas or dust jets. Still, the signal pulsed there, as if the void itself had answered. The Meerkat telescope recorded two nearly identical spectral lines, separated by an infinitesimal velocity difference. They moved with almost mathematical precision, as if each molecule knew its destination. The calculated temperature of the active region was approximately -43 degrees Celsius, 230 Kelvin, bitterly cold and nearly motionless, yet it still exhibited a certain vitality. Scientists call this phenomenon thermal expansion, an extremely subtle effect caused by molecular motion, yet within it lies a certain cosmic poetry. Of all the responses the universe might offer us, it chose the softest, most delicate voice. This is a whisper from a distant object, a fleeting passage through our solar system, perhaps its first and only journey here. It marks humanity's inaugural radio astronomical observation of 3I Atlas, a historic moment. We have not only observed an interstellar visitor for the first time, but also heard its voice. Most astonishingly, this signal was detected when 3I Atlas was positioned nearly behind the Sunday, less than 4 degrees from the solar limb. This presented an extremely challenging viewing angle where even the slightest deviation could have drowned the observation in noise. Yet the signal miraculously emerged stable, precise, and almost certainly not mere coincidence. In that moment, some couldn't help but recall the famous "wow" signal detected. In 1977, that was a unique, unexplained radio transmission from a nearby region of the sky, the very area 3I Atlas is now heading toward. Is this mere coincidence? Perhaps, yet it's intriguing that nearly half a century later, the heavens seem to be offering some kind of response from the same direction at a similar frequency. Today, 3I Atlas continues to drift away from us, traversing the cold outer reaches of the solar system. Yet the radio echo it left behind raises more questions than it answers. If this captured voice is entirely natural, it confirms we are dealing with a living comet capable of responding to light and heat. But if it contains something else, some mechanism beyond simple molecules, some controlled behavior, then perhaps we are still listening without truly understanding what it seeks to convey. Space rarely speaks, but when it does, every signal matters. The challenge now lies in deciphering whether 3I Atlas is merely whispering in cosmic silence or attempting to communicate something we have yet to comprehend. If you've read this far, stay tuned for our ongoing exploration. From this moment on, we will not only observe the visible, but also strive to perceive the elusive signals. The next transmission from space may fundamentally reshape our understanding of cosmic silence. The latest images captured by 3I Atlas reveal an unexpected discovery. On the 5th of November 2025, the Lowell Discovery Telescope in the Arizona desert captured this interstellar visitor. In the photograph, 3I Atlas appears as an intense point of light surrounded by a soft halo, almost like a thin atmosphere. Yet astonishingly, it displayed no comet tail, no visible trail of material, nor any dust stream sculpted by solar wind, like a comet traversing the Sunday without leaving a trace. This conspicuous absence is what puzzles astronomers most. Calculations indicate that during its solar approach, Comet 3I Atlas lost over 13% of its mass. This mass loss should have been sufficient to form a massive tail, a spectacular trail stretching millions of kilometers. Yet the sky remains clear and silent, showing no hint of a luminous band. The simplest explanation might be an observational angle issue. When these images were captured, 3I Atlas was only 13 degrees from the Sunday, as seen from Earth. If the tail was directly behind it, we would be looking straight into it and naturally unable to see it. Yet even so, something still seems off. In July of that same year, the Hubble Space Telescope observed 3I Atlas from a similar viewing angle and recorded a peculiar structure, an antimatter, a trail of material seemingly pointing in the opposite direction of the typical comet tail, toward the Sunday. If Hubble could detect this antimatter at a 10-degree angle, why does the Lowell telescope now see nothing? Faint blue light observed through a green filter indicates the presence of carbon molecules around 3I Atlas, but their concentration is extremely low, far too minimal to account for the previously reported 13% mass loss. It's as if this object has partially disintegrated without releasing significant dust or gas, leaving no obvious trail. Some scientists speculate that 3I Atlas might possess a denser internal structure, perhaps composed of materials like metallic ice, capable of withstanding the Sunday's intense heat and powerful solar wind. Others suggest it may have released only invisible gases undetectable by optical cameras, but some propose a bolder hypothesis. What if 3I Atlas isn't merely reacting passively to the Sunday, but somehow controls the manner of its reactions? If an object could autonomously decide when and how to release energy, it might cleverly conceal its activity. It could appear completely motionless at certain moments, even while undergoing intense internal changes. It might even hide crucial activities in plain sight. Though this hypothesis may sound implausible, 3I Atlas's anomalous behavior remains difficult to fully explain using established comet theories. A celestial body that generates heat loses mass, yet leaves no discernible trail, undoubtedly challenges the logic of our current astrophysics. Over the coming weeks, as the angle between the Sunday and 3I Atlas gradually increases, Earth-based telescopes will observe it again, this time from a more oblique angle. This presents an excellent opportunity to reveal whether it harbors a hidden tail or if this interstellar visitor belongs to an entirely new class of celestial objects we've never encountered before. For now, scientists observe only a stationary point of light, no tail, no clear explanation. Yet the cosmos seldom remains silent for long. Days later, everything changed. When 3I Atlas reappeared in our telescopes, the seemingly tranquil void of space revealed a colossal structure, a network of jets and tails stretching millions of kilometers, as if dormant space itself had awakened. This time, the spectacle captured by the telescope no longer resembled a simple natural phenomenon, but rather a vibrant living entity. From utter stillness to the first images revealing 3I Atlas in its true form, only 4 days had passed. On the morning of the 9th of November 2025, two groundbreaking observations completely overturned astronomers' understanding of this interstellar visitor. Frank Nieblin and Michael Buchner used two separate telescopes to capture a series of 5-3-minute exposures. The images displayed on screen surpassed everyone's expectations. 3I Atlas revealed massive jets stretching millions of kilometers, forming a magnificent web of light across space. Two primary jets, like cosmic tides, pointed directly toward the Sunday. A third, more slender jet extended in the exact opposite direction, its length equivalent to the apparent diameter of the Sunday or Moon as seen from Earth. For the first time, this interstellar visitor displayed such astonishingly explosive activity, not only exceptionally active, but also on a colossal scale. The measurements were staggering. The jets span nearly 1 million kilometers in width, while the primary tail stretches over 2.8 million kilometers. Such colossal structures emanating from a relatively small object appear to reshape the very void around it. All this unfolds in the distant reaches of space, over 300 million kilometers from Earth. For astronomers, such immense scales are difficult to comprehend. The dimensions of these jets exceeded any feature observed by the Hubble Space Telescope months prior by over 1,000-fold. If 3I Atlas were merely a natural comet, its ejector would have had to erupt continuously at an unbelievable velocity for months. Preliminary calculations suggest its mass loss rate could reach as high as 50 billion tons per month, nearly equivalent to the total mass of the object's core itself. From that point onward, a series of even more perplexing anomalies began to emerge. If such massive mass loss were genuine, 3I Atlas should have disintegrated long ago. Yet it remains intact, showing no signs of fragmentation, and its brightness has not significantly diminished. It appears some mechanism we do not yet understand is preserving its integrity. Even more astonishing, These ejecta appear highly concentrated and aligned in a linear fashion, as if governed by precise control. The antitails facing the Sunday maintain an unusually stable shape, with densities seemingly sufficient to resist the powerful pressure of the solar wind, a feat virtually impossible for any naturally formed comet. Achieving such resistance would require ejected particle densities millions of times higher than the solar wind itself. It resembles an invisible current forcibly pushing the surrounding space backward. Based on these perplexing measurements, some scientists speculate that 3I Atlas must have a diameter of at least 10 kilometers to be a massive celestial body composed of ice and rock, far exceeding the mass of typical interstellar objects. This presents another paradox. The probability of such a massive object accidentally drifting into our solar system from interstellar space is calculated to be only about 1 in 100 million. Statistically speaking, this possibility is minuscule, bordering on impossible. Thus, a bolder question began to surface in scientists' minds. What if this isn't an accident? What if these jets we observe aren't natural material eruptions, but rather a form of artificial propulsion? This analogy holds considerable appeal. Our own chemical rockets expel gases at speeds of about 5 kilometers per second. By comparison, the vapors released by ordinary comets travel much slower. Our ion thrusters can already achieve speeds of 50 kilometers per second. If more advanced technology could utilize more efficient propellants, then a fraction of the mass would suffice to generate the same thrust. Suddenly, many previously puzzling phenomena seem plausible. Multiple, precisely directed jets, unusually high densities, resistance to solar wind, all align with some form of advanced propulsion system. What if 3I Atlas isn't just an ordinary comet? While this hypothesis remains speculative, it can no longer be easily dismissed. When something exhibits behavior entirely beyond our known laws, science must seriously consider seemingly impossible possibilities. 3I Atlas may be naturally formed, but it could just as well be an artificial object, a lost interstellar machine powered not by simple gas ejection, but by a propulsion system driven by some intent we have yet to comprehend. As observatories prepare to greet 3I Atlas at its expected perihelion on the 19th of December 2025, a question echoes among astronomers, engineers, and all who dream of the cosmos. What exactly are we seeing? Merely a massive chunk of ice, or an interstellar traces waiting to be discovered? The answer may lie within the spectral data soon to be captured by the Hubble Space Telescope and the James Webb Space Telescope. Hidden within the invisible details of those ejector components could be the key to unraveling the mystery of this enigmatic visitor, which has transformed initial fear into profound fascination. Yet it bears repeating. The hypothesis that 3I Atlas might possess propulsion systems or technological origins is merely one among many speculations, an attempt at scientific reasoning about a phenomenon we do not yet fully comprehend, and no conclusive evidence currently exists to suggest 3I Atlas is an artificial object. What we possess are merely anomalous physical phenomena challenging existing scientific models. In the realm of science, questioning and exploring the unknown is an integral part of the process of continuous progress, not based on blind faith. Just as telescopes worldwide race to analyze the latest records of 3I Atlas, a new celestial object appeared in the sky. In the early morning of November R, Liaotenlin Arshawu, astronomer Gennady Borisov, renowned for discovering the interstellar comet R.I. Farisov in Liaotenlin Ishijou, identified another visitor, a comet designated Cephei Liaotenlin Arshawu V. Fei Borisov. This discovery immediately captured widespread attention within the astronomical community, occurring shortly after the intense activity recorded by 3I Atlas. The near-gen simultaneous observation of two such rare celestial bodies seemed remarkably coincidental. However, this coincidence appears to be limited to timing alone. The orbital path of Cephei, Liaotenlin Arshawu V. Fei, differs drastically from that of 3I Atlas. Its orbit is highly inclined, forming an angle of Yo-Yo-Sen degrees with the average orbital plane of our solar system's planets. This angle causes it to travel in a direction nearly opposite to most known celestial bodies, explaining why its presence was difficult to detect earlier. Initially, Cepheid, Viphe's peculiar motion, led some researchers to speculate whether it might also be an interstellar object, like Senai Atlas. However, further orbital analysis has shown this is not the case. The comet's orbital eccentricity is very close to E, meaning its orbit is extremely elongated, almost a straight line, yet still bound by the Sun's gravitational pull. Simply put, Cepheid Viphe most likely originated from the Oort cloud, a vast region of frozen celestial bodies located at the very edge of our solar system. The Oort cloud acts like a vast warehouse storing billions of tiny frozen celestial bodies. Occasionally, gravitational perturbations from the giant planets within the solar system, particularly Jupiter, disrupt the orbital equilibrium of these bodies, pushing some inward toward the solar system's center. This is likely what happened with Cepheid Viphe, its similarity to Senai Atlas, both lacking a visible coma, is merely superficial. The absence of a coma can be explained by various factors, such as the angle of observation, distance from the Sun, intensity of reflected light, or even the type of material released by the nucleus. Each comet reacts uniquely to solar radiation, resulting in distinct appearances when viewed through telescopes. Precise orbital calculations confirm that Cepheid Viphe and Senai Atlas never came close to each other. Even at their closest orbital points, the two orbits remained over lion kilometers apart, a distance sufficient to rule out any direct physical connection between them. These were simply two independent cosmic events, observed consecutively in time, yet lacking any direct causal relationship. Nevertheless, this new discovery holds significant scientific importance. The successive observation of two such extraordinary celestial bodies within such a short time frame powerfully demonstrates the rapid advancement of our modern astronomical observation capabilities. Today, both ground-based and space telescopes possess the ability to detect faint, orbitally inclined minor celestial bodies, a feat unimaginable just decades ago. Astronomers are currently conducting continuous monitoring of Cepheid Viphe. Over the coming months, its orbit will be determined with greater precision, and new observational data will help confirm its exact origin and material composition. This information will provide valuable clues for better understanding how comets form, how they move within the solar system, and what changes occur when they enter the inner solar system. In astronomical research, coincidence does not necessarily imply mystery. Rather, it often presents opportunities for learning and advancement. Each newly discovered celestial body serves as a test of our existing theories, propelling us to continually refine our understanding of the cosmos. Though the ultimate answers may remain undisclosed, every cosmic visitor reminds us that the universe still conceals numerous phenomena beyond our comprehension, phenomena that only time can ultimately reveal. Both Senai Atlas and Cepheid Viphe have left their unique marks. These two distinctly different celestial bodies, observed by chance, remind us once more that science's true allure lies in the unknown, not as a threat, but as an eternal invitation to explore. Senai Atlas has now completed most of its journey through our solar system. Since its close encounter with the Sun, it has been slowly receding, leaving behind a long trail of mystery and discovery. In the weeks leading up to November Shusen, Atlas became the target of a global race among telescopes. Each newly captured image revealed further details about its structure, behavior, and velocity. It was during this period that scientists documented its incredible massive jets, peculiar antitail structure, and the astonishing resilience of its constituent material. Today, 3I Atlas remains visible in the early morning hours, and its observational conditions from Earth continue to improve. Both professional and amateur telescopes continuously track its trajectory, precisely measure its brightness, and monitor its minute motion changes. All indications suggest this interstellar visitor maintains a steady course, gradually receding from the Sunday while drawing closer to its closest approach to Earth, anticipated around the 19th of December 2025. Anticipation for this moment is palpable. During this close encounter, 3I Atlas will be approximately 269 million kilometers from Earth. This distance is sufficiently far to pose no threat to our planet, yet close enough to enable the most detailed study of this interstellar object to date. Major space telescopes, such as the James Webb Space Telescope and the Hubble Space Telescope, are fully prepared for this pivotal moment. The primary observational focus will be on spectroscopic studies. This technique identifies an object's chemical composition by analyzing the light it reflects or emits. Through spectroscopy, scientists hope to reveal the elements composing 3I Atlas's jets and ultimately determine whether it is a typical comet, an ice-rich asteroid, or some intermediate object we have yet to fully understand. This will also be a crucial opportunity to test various hypotheses proposed over the past few weeks. The purpose of this research is not merely to confirm some sensational, extraordinary discovery, but to gain deeper insights into how celestial bodies from other star systems respond to the energy of our Sunday. These invaluable data will contribute to a more comprehensive understanding of planetary system formation and how matter behaves as it traverses interstellar space over millions or even billions of years. Thus, the study of 3I Atlas marks not the conclusion of a mysterious tale, but the beginning of a new, promising phase of learning. With each new measurement, each meticulous analysis of light, science advances a small step toward the ultimate truth. The true final judgment does not come from a dark, alien cosmic object, but from humanity's own capacity to comprehend the unknown based on irrefutable evidence. As 3I Atlas continues its interstellar journey, new observational updates will likely follow. Its brightness may gradually fade, its jet activity may subside, and it will slowly vanish from our view, ultimately returning to the deep, cold interstellar void. Yet, it leaves behind not silence, but vast scientific data, precise measurements, and countless thought-provoking questions. These will continue to nourish the powerful force that has driven us since science's inception, an endless thirst for answers, not mere blind faith. When telescopes precisely target this interstellar visitor, again in December, humanity will once more gain the opportunity to listen to its narrative, not through words, but through light that has journeyed billions of years. It is this very light that over the past months has repeatedly guided us to gaze at the heavens with ever-intensifying curiosity. 3I Atlas is now embarking on its journey home. As our telescopes continue to record its final light signals, this interstellar visitor has already distanced itself from the Sunday, plunging once more into the dark interstellar void. Its light is gradually fading, as if the universe is slowly drawing the curtain on this magnificent spectacle that lasted only a few months. Yet, what it leaves behind is more profound than any dazzling image. It leaves behind countless questions and a profound reminder that the cosmos remains far beyond our comprehension. During this fleeting journey, 3I Atlas compelled us to re-examine our place in the universe, no longer viewing it as a distant, cold backdrop, but as a mirror reflecting our own curiosity. It reminds us that science isn't about finding ready-made answers, but about the courage to pose questions that currently defy solution. Why could such a massive celestial body move with such precision? How could it remain intact despite losing so much mass? Beyond what we know, what else traverses the same cosmic silence? These questions did not deter scientists. Instead, they ignited an even stronger desire to explore. For the true meaning of exploration lies not in discovering entirely new things, but in understanding the cosmic mysteries that have always existed, yet remain incompletely known to us. Now, 3I Atlas is gradually fading into the distant shadows of the solar system, growing ever more distant from us. When it finally vanishes entirely from our telescope's view, what remains will be the impact it has had on us, a powerful desire to keep observing, to keep exploring. Perhaps someday another visitor from a distant galaxy will reappear in our field of view. When that day arrives, we shall be better prepared, equipped with more advanced instruments, sharper eyes, and a more open heart, to comprehend the unknown that approaches. The universe does not actively convey messages to us. It simply exists in silence. Yet sometimes this very silence holds profound revelation. Countless unknowns await our exploration. Mystery is part of the universe's beauty, and every ray of light traversing space reminds us that human curiosity can likewise span the cosmos. If this journey with 3i Atlas has given you a fresh perspective on the starry sky above, allowing you to feel the vastness and mystery of the universe in an instant, then please share this inspiration. View the sky with fresh eyes and let the echoes of the cosmos resonate further. Like this video, share it with more people, and leave your thoughts in the comments, because every interaction, every comment, and every friend joining this conversation helps the algorithm deliver this miraculous story to more minds and hearts yearning to understand the universe's mysteries. The universe may not need an audience, but we need it to constantly remind us of our own insignificance and our great potential to explore the unknown. When the trajectory of 3i Atlas finally vanishes into the endless darkness, something deep within us is quietly awakened. We firmly believe that the next visitor from the stars has already set off from distant interstellar space, and we will be here waiting expectantly for its arrival.